So, hi all, it's my pleasure to introduce Dr. Sebastian Olschewski. Dr. Olschewski is currently a postdoc at the University of Basel. Despite being young, Sebastian already has a very impressive publication record, including, among others, publications in PNAS, JEB General, Journal of Economic Psychology, and much more. Sebastian's research deals with understanding economic behavior through experimental methods and computational cognitive modeling. We also know that Sebastian likes tea. I can assume maybe he prefers tea over coffee, but I will not go into that. Uh, Anyways, we will proceed as follows. So now you will have about 40 to 45 minutes for your presentation, and then we will have about 15 minutes or so for questions. And then at 4, those who have to leave will be able to leave. And if it's fine with you, we will stay for additional about 15 minutes of informal discussion.
Sure.
And now, Sebastian, the floor is yours.
Thanks so much, Yefim, and yeah, thanks all the organizers for the seminar. As I told you already, I like the seminar series a lot, and I'm even more happy that I have the chance to present now. So thanks for your efforts of organizing, and yeah, thanks everyone for tuning in today. So I want to talk about being risk averse and risk seeking at the same time, an apparent preference reversal in valuations and decisions from experience. And this is the main body of this is work together with Benjamin Scheibehenner and Konstantinos Tsetsos. So just a quick intro about risk-taking and risk preference. So I think you all agree that risk-taking plays a big role in many small decisions, but also in many very big and important decisions. For example, saving for your retirements. At the stock market, you face financial risks. Or if you decide where you want to live, you can face environmental risks, for example, of flooding or of wildfire. Also in the health domain, if you decide to do a pre-screening or whether to get vaccinated or not for a new disease, you face health risks. And while we all know that people differ in these risks, and this is also fine for us, economic rationality always demands at least a little bit of stability in order to meaningfully talk about risk preferences and individual differences within there. And we can decide what the scope is of the stability, but at least some type of stability across context is important to have a useful term here. But since the 70s, one very classic study shattered a bit this idea, and these are the classical preference reversals between valuations and choice. And just to remind you here about one example, here on the left-hand side, you have a lottery where you can win $10 with 28 out of 36 probability. And on the right-hand side, you have a lottery where you can win with 3 out of 36 probability, $100, and else nothing in both cases. And if you ask people directly which of the two bets or lotteries they want to play, they usually prefer the P bet. So this is the one with a small reward, but a very relatively high probability. But if you ask them for their certainty equivalence or how much they would be willing to play either of the bets in isolation, they usually give the higher monetary amount to the right lottery here, the dollar bet. And yeah, this is problematic for this notion of economic rationality and the idea that across context there are some stable risk preferences. But yeah, these decisions were all in what we often call decisions from description. So for these two lotteries, they are very stylized. We know exactly which probabilities and which outcomes we can get. And one could argue that, especially in the examples I made above, but also in many decisions in our daily lives, we don't have these precise probabilities available. And maybe we learn more over experience in what environment we are and what we can get and win. And to this, I want to make a very small digression to decisions from experience and cognitive processes. And this content here is mainly taken from a perspectives article that some colleagues and me published last year. So first, we try to review a bit the literature. And again, if we go through the three domains, financial, environmental, and health risk, we can find in all of these domains good evidence that personal experiences matter. So for example, stock market participation matters a lot. It matters a lot what your personal experiences are. If you are unlucky and you just start at the financial market in a time where it goes down, this has long-term effects on your propensity to enter the stock market again. But then also for environmental risks and, for example, climate change and environmental policy attitudes, it matters a lot what personal experiences you made. And finally, also if you weigh the risks or benefits of disease screening and vaccine side effects, personal experience, vicarious experiences have been shown to shape your attitude and your propensity to engage in these things. And so that's why I think there are good reasons why we want to study decisions from experience. And we do this usually in these two paradigms, in the sampling and the repeated choice paradigm. They differ from each other then that in the sampling paradigm, you see, for example, two options here, A and B, and you can draw samples from them, so make experiences with each of these options without any consequences. And then either when you sampled a predetermined amount of time or when you yourself think you sampled enough, you can make one consequential choice. So which of the two options do you want to have for an additional draw? In contrast, in repeated choice, this is a situation where every decision matters. So again, you have no information about option A and B usually, and then you sample from them, you choose between them, but usually every choice you make is already payoff consequential or at least consequential for your score that matters in this task. And yeah, we will focus here more on the sampling paradigm, but yeah, these are just the experimental paradigms we have. And the main claim of this perspectives article is that to better understand or to make this connection between this experimental paradigm and these important real-world decisions we might be interested in, like in the environmental and the health domain, at the financial markets, we need to better understand the cognitive processes that shape choices in these paradigms. And we classified this here in three different broader areas. First one is attention and perception, then memory, and then learning. And in attention and perception, for example, it plays a big role how people selectively pay attention both to the set of available choice options, but also to the experience and the feedback they made. Then numeric cognition plays a big role. So how do we represent numeric information in the brain, and how do we integrate different sources of numeric information? But then there's also non-numeric perception, in particular in consumer goods and so on. Then memory plays a big role because very often when we make a decision, the experiences we made or the information we gathered is not readily available at the time we make a decision, right? So we have to recall this from memory. So more research, we argue there, is necessary to better understand how episodic memories, so what you personally experienced in the past, but also semantic memories, so what are your associations in a given choice situation, how this affect decisions from experience. And then finally, what we grouped here under learning. So we know that it's usually we have many different sources of information available. So it's also very important to better model and understand how people integrate feedback from different sources. Then we have this model-based aspect and pattern recognition. So very often people come with mental models into a choice situation. So they have ideas about the data generating process or about causal relations within a certain context. And this shapes then also how they deal with the observed experiences they made. And finally, also social learning plays a big role. Like often we talk to others about similar situations. So these are vicarious experiences. Then the question is how information is communicated, or what you infer about the motives of the other person of telling you and so on, which makes the whole situation even more complex. But yeah, the main claim here is that to better understand the complex real-world situations, maybe the things that are more stable is not so much the choices that we observe in these experimental paradigms, but more the cognitive processes that lead to these choices. And if we understand those, we can also better make predictions for real-world decisions. And the project I want to present you today tries to do this and focuses in particular here on selective attention and numeric cognition. And that's what I will go into more detail now. So first, computation explanation, risk aversion. So there is, of course, risk aversion as a direct, as modeled by utility functions, but we can also go one step further and think about more generally about research on psychophysics that very often found a concave representation of stimuli in the real world, in weight, in length, in luminosity, and so on. And more recently, it has been also found that numbers are represented in this compressed fashion, which you see here on the right-hand side. So we have numerosity on the x-axis, and then the representation here in a compressed fashion. And one way to model this is with a power utility or a power function, so to say, with an exponent between 0 and 1. And this is how you can, if you have a stream of numbers that you observe, then the representation here could be compressed and also has an error term because we assume that the representation is somewhat noisy. And this can, of course, explain a risk aversion, as we all know, in particular because if you take variance as your measure of risks, then for high variance options, the very high outcomes are discounted disproportionately more than the very low outcomes, and therefore you have lower representations for the high variance than for low variance options. But then these numeric representations, we know they're also affected by the context. We don't do this in isolation. And with context, I just mean here the options or the experiences you make within one scenario. So in the easiest case, on the right-hand side, think about there are just two options where you see feedback or samples from these options at the same time. So here you see option A and option B, and you see 180 and 130. And there are a couple of recent research showing that how we represent and deal with this information is shaped by the context, that is by the other option in the learning process. So for example, the studies from Sophie Bavard and Stefano Palmentieri and other colleagues showed that there's some range adaptation. So individuals represent options relative to the available ones. And you can see this in their very clever design. You see this then if you choose out of the learning context. So if you think you also have options C and D, and option A is maybe better than option B, people like to choose it. And option C is better than option D, they like to choose it. When you then ask them to choose between option A and option D, for example, then people often choose the option that was relatively better in their local context, irrespective of which had really the higher numbers or higher values. A similar mechanism are frequency-based valuations. So in this case, it can be shown that individuals choose options that have higher numbers most of the time within a context. So if you just observe which option has the higher outcome or higher number, and you count this, then this is a very adaptive, you can say, process. It's very parsimonious, but you can also show that this is, of course, not always optimal or can also lead to inconsistencies. For example, we showed this in a paper where we looked at skewness preferences and showed that they can be completely explained just by reversing the frequency of those numbers within a stream that win most of the time against another option in a local context. But here, I want to talk more specifically about one mechanism, and this is the selective integration of number representation, because this is interesting because it can predict risk-seeking in decisions from experience. And this works as follows. So we have now these two options, A and B. And let's say again, the individual samples at time t are called XA and XB. And now the representation here of the sample in XA also depends on what you observe in XB. And this is characterized here by this theta function. And they are very different algorithmic formulations, how you can implement this idea. But one easy one is you just have these basically step functions where you say, okay, if the current number is larger than the number of the competitor of the other option, then I overweight this. So this is signified here by 1 plus this omega. And if it's smaller, then I underweight it, so 1 minus the omega. So assumed here that there's a symmetric effect. And as long as this omega is larger than 0, and let's say smaller or equal to 1, then we have this overweighting of numbers that in a certain context are the higher ones. And just for the intuition, and this can produce risk-seeking, because, of course, the high variance sequences produce the more extreme outcomes. So they are both in expectation higher and lower than sequences with a low variance and same EV. But then selective integration basically puts more emphasis on the high outcomes. So when the high variance option basically shines and ignores basically when the high variance outcome produces very low effects. Yeah, that was the intro and the theoretical part. And now we come to this recent work of ours, where we also see some data and want to test this. And if you recall, yeah, going back to this idea of preference reversals, given the theory we just revised, we see that we can predict risk aversion, but also risk seeking in these decisions from experience. So the question was that motivated us, do we find a preference reversal in decisions from experience between valuations and choices, given the theory we have and given what we know from decision from description? And if we find this, can we explain such a reversal with these cognitive processes? And then a third question we had is with respect to the stability of individual risk-taking. So how stable are people in valuation and choice with respect to their risk-taking, and how is it affected maybe by these cognitive processes we assume? And with this, we continue with some data. So in study 1, where we wanted to establish this phenomenon, we started and we do decisions from experience, as I said, in the sampling paradigm. So first, participants see some samples of distributions, and then either they make a choice or a valuation, and they always see 12 numbers. So they cannot decide how often they want to see them. We just present them to them, and they are automatically unfolded to them. So in the choice task, you see these two options, yeah, A and B, and you see both samples simultaneously from both options, and then 12 times unfolding. And afterwards, participants make one consequential choice from which of the two options they want to get an additional sample. And then in the valuation, there's just one option that participants see. Again, they see 12 numbers from this option, and then they have to give their willingness to sell or willingness to accept, and we incentivize this by a BDM auction so that they are incentivized economically to state their true certainty equivalence. So how much is it worth for them to engage in this option? And of course, the options in choice and valuation were the same. There was a within design. The participants either started with the valuation or with the choice, and then also had the other conditions. And we had normally distributed outcome distributions, different levels of EV, and then 2 levels of SD, which we also scaled at the EV. So we have this coefficient of variability, that's the SD over the expected value of the options.
Sebastian, I can only assume that when you ask them about the value, you ask about one choice, right? Like in the sampling case.
Yeah. Mm-hmm.
So how much you will value one choice, right, of this?
Yeah, but they do is
yeah.
repeated. I mean, there are repeated trials, right? So we have several trials, and in each trial, they see the 12 numbers, either from two options in the choice or from one option in the valuation, and then they make one decision. Or
no, but I mean the value, the question about how much you value it, how much you want to pay for to participate in this, it's only to participate in one choice from this distribution.
Yes,
right?
yeah, one draw. Yeah, one draw from
Okay.
distribution. Correct. Yeah.
Thanks.
And you do a random incentive system that in the end you pay one of the choices made, or is every
Yes.
decision paid?
No, one out of choice and valuation in total is then drawn and paid out for real. Yeah.
Okay, the standard thing. Okay.
Yeah, it's good. I mean, we are now coming to the data, and this is the general framework. I want to present you 4 studies. So any more clarification questions for the method, that would be good time. If not, then we just go to the results. So in valuations, what you see here on the y-axis, you have the percentage deviation from the experienced mean. So the actual mean participants saw, and then we subtracted this by the valuation, and we divide, just to standardize it across trials, we divide it by the expected value because we varied that a lot. And what you see at the first time, the values are all negative. So this means that overall participants gave lower valuations than the expected value of these options. So this shows already a sign of risk aversion, you could say. But then importantly, if we look at the effect of variance, on the right-hand side is the high variance trials, and on the left-hand side, the low variance trials. There's a clear tendency that people give lower valuations for high variance options than for low variance options. But now if we look at the choices, we see the opposite pattern. So here you see on the y-axis just the percentage of risky choices, meaning the choices with a higher variance in the direct comparison, high versus low variance option, and same expected value. And here people clearly prefer the high variance option. So this is basically a preference reversal in the aggregate, in the sense that people prefer or choose or value as if they are risk averse, but choose as if they are risk seeking. And if we think about these computational models, how we could explain this, we would need both of these mechanisms I stated at the beginning. So here, if you have a small example, so a low variance option here with the options, or with the samples 190 and 210, and then a high variance option, which is more extreme outcomes. And then you think about that you represent these numbers and then aggregate them to a final valuation judgment. And you do this with the power function I introduced and the exponent between strictly between 0 and 1, then you would see that the low variance option always has the higher value. But then if you add the selective integration mechanism with this omega here, then you would see, okay, for the first sample, you see the 190, and you see on the other options the 220. Here, you would basically down value or downweight this a bit, the 190, and overweight a bit the 220. And the other way around at the second option. But then if the omega is significantly larger than 0, then you can get the reverse, and people give higher values to the high variance than to the low variance option. And the hypothesis I want to explore now in the remaining studies is, does this degree of selective integration, this W, can this depend on the context, and can we shift this around? And there are 2 ways we try this, and we are guided just by looking at what are the differences between the 2 tasks, right? And the first difference that comes to mind is the presentation format. So we saw in the choices, you saw these 2 streams simultaneously, whereas in valuation, you only see 1 stream. And this process of selective integration, basically selectively paying attention to higher outcomes, this is, of course, much easier if you see the samples directly next to one each other compared to if you see one stream and then maybe see the second stream. Because if you do see both streams sequentially, then during the second stream, basically, you have to recall from memory what were the samples you saw before, and then this process is much more effortful. So what happens with the risk-taking pattern when we change the presentation format? So if we give valuations, but with two streams, and choices where one stream is presented after the other. If the presentation format could explain this preference reversal, then we would see a complete swap, right? Then people could be risk-seeking in valuations and risk-averse in choices. And that's what we wanted to see. So very straightforward design. Everything is the same as in study 1. Just now in the choices, you see here on the right-hand side, now we have again two options, one on the left, one on the right, but you first see all samples from option A, and then you see all samples from option B, and then you choose one or two. And in the valuation, which is now in the simultaneous presentation format, you see two options, A and B, simultaneously presenting the 12 samples, and then you do an independent valuation of the left option and an independent valuation of the right option. And yeah, what you see here is again the same plot as before. So the percentage deviation from the experienced mean. You see also again that overall the valuations are below the expected values of the options, so some indication of risk aversion. However, the effect of variance is reduced, yeah? So it's not a strong difference between high and low variance options anymore. But importantly, it's also not a swap, so you don't see risk seeking now in valuations. And for choices, similar pattern here. Actually, the risk seeking has disappeared. Participants choose now the high variance option, not significantly different from 50%. So we see the presentation format does reduce the reversal, but it did not reverse basically the risk-taking pattern. So that's why we think there's a second mechanism going on here, and that's the task demand. So in choices, of course, we make something like a relative ordinal judgment, right? So you just have to say which of the two options you like better. Whereas in the valuation, you make absolute judgments, right? You have to, even in monetary equivalence, you have to state in monetary equivalence how much you value a given option. And in principle, from the valuations, you can infer your choices, right? But not necessarily the other way around. So from the choices, you know which one you should give maybe the higher valuation, but you don't know the absolute value you should give. And this also implies that the selective integration mechanism is very adaptive in relative judgment tasks, and this has been shown by Tsetsos in prior publications. So it's a very parsimonious strategy that is very accurate, in particular, if you have differences in the expected value. Then this selective integration can very reliably identify the better option. But yeah, in absolute judgments, it is not very helpful because you usually don't have a realistic representation of absolute value. So in the next two studies, what we wanted to do is we wanted to give participants the same task demand or both task demands. So they have to do choices and valuations at the same time. And this should align the integration process in both tasks. So that would mean reducing the impact of selective integration on choices, but also potentially increasing the impact of selective integration on valuations, because while you try to do absolute valuations, you also much more keep in mind that you also have to do relative comparisons. And now we varied the presentation between study 3 and study 4. So we start in study 3 with the simultaneous presentation mode. So again, you have two options and you see all samples at the same time unfolding. And then in the standard paradigm, which we also have here as a replication, you just do the choices. But here in the valuation plus choice, we first ask you to independently value each of the two options. Then we have a 3-second black screen, maybe to avoid that participants immediately on the screen maybe see what they choose higher and reduce a bit the consistency motive. And then they make a choice which one of the two they liked better. And here is the results. Again, same presentation. For the valuations, we see, again, overall risk aversion, valuations below the mean, and again, a reduced effect of the variance as we saw in study 2. So the effect is very small of variance. And then in choices, for the only choice condition, again, we have the risk seeking, pretty similar to study 1. But now if we have the valuations first, the choices drop again close to 50-50, so no risk seeking anymore. And importantly, this is now, although the presentation format is basically the standard one for the choices where we found risk seeking before, right? So it's not that the presentation format is different, it's really just that the task demand changed. So people had to also do the absolute valuations.
I'm not sure. So maybe this is what your argument is, but after you do the valuation, so of course your choice is influenced by your valuation. And if you don't get the effect in the valuation, so it only makes sense not to get it when you have the subsequent choice, right?
Yeah, you can ask so, but you could also see, I mean, they don't go back to risk aversion, right? So there's still a residual. It's not like they're just 100% following the valuations, because then you should see it to go below 50%, which is not what we observe. But it takes this point, we also thought about it, and we have in study 4, maybe a design that you will like better.
Okay.
Because here, yeah, we do a surprise query. So now the presentation is sequentially again. So that's as you see only one stream of samples at a time from one option. The idea is you see the first option stream first, then you always do a valuation from this first stream. Then you see the stream of the second option, and then we do a surprise, either ask you for a valuation for the second or to make a choice between the first and the second. So in that sense, we now have valuation and choice data from different trials. So the consistency motive should not be there anymore. Yes, and what we see here, I mean, this is in particular interesting for the valuation data, because now we have the standard format of valuation where participants just see one option at a time. And again, we see overall risk aversion, but we also see that the effect of variance is reduced. So this shows that, again, the task demand also plays a role here, even though there should be no consistency. And yeah, and the presentation format is the same in which we saw this stronger effect of variance before. And then for the choices, they are again close to 50-50. They're actually the first time below 50%, but yeah, not significantly so. But here we see, okay, in this format where you see sequentially the choices, and you always have to think about also absolute values, you definitely don't see risk seeking anymore. And yeah, this concludes the studies I wanted to present. I have now some summaries of the results. So again, in the valuation, now a little bit differently presented. So I show you directly the difference between high and low variance. And here again, you see in study 1, in the standard format with individual presentation of the samples and only valuation task, we have the strongest effect of the variance. And this is stronger than in any of the other 3 studies. So in particular, it's stronger than if you present simultaneously 2 options and ask for independent valuation. It seems like this integration process interferes with it, even though it's not an adaptive process in this case. But it is also there if you have the same presentation format individually, but you ask, or there's a task demand that you could also be asked for a relative judgment. So this alone also reduces the effect of variance. But critically, yeah, never to the extent that you would observe risk-seeking in valuations. And then similar, we can conclude for the choices. Again, in study 1, simultaneous presentation and task demand is only for the relative comparison. That's the only condition where we significantly find risk-seeking. In all other conditions, it is reduced, in particular in study 2, where we present the two options sequentially, one after the other, it is reduced, but also in study 3, where it is presented simultaneously, but before you do valuations. So you have also in mind that you have to make absolute value judgments. And now we come to the third question about the individual correlations. So I grouped this here across all studies already. And it's a very clear pattern. So in study 1 and study 2, there's no correlations between valuation and choices. So valuations are here on the x-axis in each of these 4 panels. It's the deviation or the difference in the valuations for high minus low variance. And on the y-axis is the percentage of high variance choices. And you see, study 1 and 2, no individual correlation. And this means that clearly the different presentation formats and the different task demands overshadow any stability in risk-taking that might be there. But interestingly, in studies 3 and 4, where we aligned the task demand and the presentation format, here we have a relatively huge effect. And we see in study 3, it's the biggest with 0.58. And maybe that could be driven a little bit also by consistency. But yeah, in study 4, where there's evaluation and choices in different tasks, it's still 0.45. So we would argue that, if you keep the task demand and the presentation formats the same, and that way control the cognitive processes, you can see the stable or some stability in individual risk-taking, but not across context if presentation format and task demand is so different.
This assumes that in study 4 you really eliminated the consistency part, and I'm not sure I'm convinced. Maybe I missed something, but they still need to give some valuation, and then they do, because they don't know that they're going to give a choice, but they are doing many trials, right? So they do know.
Exactly, but every time, so it's a surprise. Every time they don't know before they see the samples, they don't know will they do a valuation or a choice in the end.
So I would say that when I'm doing it repeatedly, I'm thinking about that I might do the choice, and I'm thinking of, so I mean, I don't think that you eliminate the consistency concern or issue, but, and actually it's nice because you have a steeper slope for study 3, and then you diminish this motivation for consistency, I will say, and then you have a bit more moderate slope, right, in study 4.
Yeah.
So it could be driven by this consistency between valuation.
Yeah.
Theoretically.
Yeah, so I would just say, I mean, this very strong consistency, in my view, can only be there if within one trial, you know what you chose for what you like better, and you made a valuation. And to be clear, in study 4, that was not the case, right? I mean, the choices or the stimuli were, of course, similar, but it was never so that within a trial, they do valuations of both options and also made a choice. Yeah.
But the task demands are cross-trials, so they think about both valuation and choice.
Yes, I mean, that's what we wanted, right? That was what we wanted as a manipulation,
Yeah.
but of course, ruling out like at least very easy consistency motives, right? That was the
Thanks.
endeavor here. Okay, just the main takeaway. So we showed a risk preference reversal in decisions from experience. So people were risk averse in valuations and risk seeking in decisions from experience within participants. And then we showed that the presentation format and the task demand, both independently but also together, significantly reduced this reversal, but they did not reverse the reversal. So we never get to the situation where they get risk-seeking in valuations and risk-averse in choices. So there is some residual motive or so in these different tasks. And then aligning presentation format and task demand enables us to elicit some stability of individual risk preferences, right? So if we just be in this very different context, then apparently individual differences in how people deal with the different presentation format and the different task demand completely eliminates stability in these risk preferences. But when we align this, we can still retain some stability. And I have some slides if I have some more minutes, or do I have to stop?
No, you have a few more minutes.
Then I have some implications, or just to think a bit about more about these results. So getting back to this idea, we need to understand the cognitive processes to better understand what's going on in these tasks, and also eventually to be better at predicting in complex real-world situations. So I think this is a good example where we can show that the cognitive processes of representation and integration of these samples shape risk-taking in decisions from experience, and importantly, to predict individual risk-taking from experience across different contexts. We need to take these cognitive processes into account, either by the design of the task or through computational models where we explicitly model these processes. And then we can also make good predictions across different tasks that, just if you look at the choices, just at the behavior, do not correlate with one another. And then for this computational model, I showed you before. So we would argue that this degree of selective integration, this omega, that this is not very stable function, basically context-free, but this really depends a lot on the context, and it can be increased, for example, if in the simultaneous presentation format, and if you prone people to look at relative judgments. These are the situations where the selective integration plays a big role, and if you present options one after the other, or if you really induce the task demand of making absolute judgments, you can reduce this omega a lot. But here's a limitation, of course. This is not the only possible algorithm that can explain this data. And I think many here in the audience can come up with other and better models. So it might be interesting in the future to try to find data sets that distinguish more between these different mechanisms. And I'm very interested to also work on that in the future. And then finally, about preferences and inference. So I described these cognitive processes here as general psychological or cognitive processes that are not confined to risk-taking per se, but should apply more generally to all type of human inference problems based on this numeric information. And just as an example from an earlier publication of ours, where we looked at valuations from experience. You see this here on the left-hand side, and again, varied variance and also skewness. And we saw this effect that people gave lower valuations for high variance than for low variance, but also higher valuations for right-skewed versus left-skewed options. But interestingly, we saw qualitatively the same pattern also in an estimation task. So in this estimation task, participants were just incentivized to be as accurate as possible to estimate the mean of the sequence. And normatively, of course, this should not be affected by, should not be biased by variance or skewness. But you see, again, that variance biased estimates downwards and right skewness biased it upwards. So it was a similar pattern there. And I think this dovetails very nicely with a recent trend, or also sometimes called in cognitive economics, where we try to find these cognitive principles in economic choices, but they're not confined to just risk-taking. They're not just risk preferences, but they are more general mechanisms that shape how we perceive, attend to, and integrate information. So yeah, with this, here's again the short summary. I thank you for listening. I thank my co-authors, Benjamin Scheibehen and Konstantinos Tsetsos, and happy for any comments either now or through my contact infos. Thank you.
Okay, thank you. And now it's time for questions. This was very interesting. Yes, Ido, you're the first one.
Yeah, I would like to try a hand-waving explanation. So not an alternative to your model, but thinking about what could be the motivation for this or what could be the reason for this descriptive value of your model.
Mhm.
And basically my argument, which is a little bit hand waving, as I already said, is that we come to the lab, you study decision from experience, but my argument is that people rely on experience in your sampling task, but also in previous experience that they bring with them to the lab. And when you give me when I have to bid and to make one final, then I worry that maybe I'm being tricked here. You know, maybe I don't know if the computer will. You know, I'm thinking about real life situation when you have to pay something on. You can either maintain the status quo or bid. So you have to decide whether you want to take a risk. You're not sure whether you're going to be tricked, yes or no. But if you are forced to choose anyway, then you have to choose. So it's not depending on you. You already are in a situation you have to choose. Another thing that happen in natural choices that doesn't happen in your experiment, and this is why my explanation is a long shot hand waving. You know, in many natural settings, you have to choose between many alternatives. So when you choose between many alternatives, it makes sense to look at a high payoff. So the positive W that you get there for the choice, this is maybe generalization from real life situation in which you have many choices, and then you should not worry, you should only worry about the good one. So pay attention only for the good one and ignore the bad alternatives. So basically my hypothesis is that maybe this biases that you observe, maybe they are generalization from natural situation in which there is important difference between choice that typically is between multiple alternatives. This is why paying attention to the best is the most important, and bidding in which you have to be careful. This is just a long shot.
Yeah, thanks. I think the second explanation for the choice task is, I would say, somewhat consistent with what I think about it, with the relative judgments that, yeah, if you do this relative judgment, what we call the task demand of the relative judgment, this can foster the selective integration and risk seeking, and as you said, also makes you more aware of these options that have high outcomes. I think that's consistent. For the other one, with this risk aversion in valuation, yeah, we didn't consider that so far. So that's an interesting point, maybe even an explanation further up. So we say, okay, this risk aversion comes here. I mean, we explain the risk aversion by a general tendency and an absence of the selective integration, right? Just that, I think that would be already enough. And maybe there's an extra effect, as you say, that people are skeptic in this pricing task. Yeah, thanks.
Just one way, actually, I ran an experiment to test that this risk seeking with normal distribution in the sampling paradigm that you guys observe and was observed in the past by your co-authors. If you play many times, we get feedback after each time, it diminishes. So we have an experiment which had 2 normal distribution for 100 trials. And initially we get 60%, but if you actually get your final pair, feedback concerning your final pair, it goes down toward 50%.
Oh, really? Okay. We had also one study where we did
kind of story. And if you want to, and here is another story about when you will get risk-seeking in valuation. If you will say, instead of you just evaluate against a computer, if you say it's a second price auction, then you get risk-seeking in valuation.
Okay. So if you
There
play
are results in the economic literature that in second price auctions people exhibit risk seeking.
Okay, that's a winner's curse.
Not something about valuation versus choice. It's something about generalization from. This is my hypothesis, of course. But you should definitely look at the literature on second price auctions that I think they found risk seeking.
Yep. Thanks.
Any additional questions? So I will ask a question, I think related to what Idon now said. Maybe I missed it, but do you think you will observe the same results in the decision from experience? Not decision, in the repeated clicking paradigm as in the sampling paradigm, or do you think you will get different results?
So for the choices, I would expect to get the same results. For the valuations, I never did this for repeated decisions. I don't know how valuations react to this repeated decision framework. That would be interesting. I'm not sure. Yeah.
I don't think you get risk-seeking in a choice between two normal distribution repeatedly.
No?
Well, we didn't get it.
Okay. I mean, we had one study where we did it with
in the
feedback
sampling
and
paradigm, which is consistent with my story.
Mhm.
I'm pretty sure, yeah, we didn't publish this result, but I think we have a result that that with two normal distribution with immediate feedback, you don't get risk-seeking.
yeah, we had one data set where we still got it with feedback. So, but we also didn't include it here. So maybe we should join forces.
Okay,
there.
that will be interesting.
Yeah.
By the way, what was the incentive structure of the participants? Again, maybe I missed it, so I'm sorry about that. I
So
mean,
for
how
choices, they just get, sorry, yeah, for the choices, they just get one new draw from the option they chose as a reward. And for the valuation, it was a BDM as a willingness to accept, willingness to sell. So we had an auction between the minimum and the maximum of the observed numbers. And then if this number was higher, then they would sell their option and would get the higher number. And if it's lower, they would play the lottery.
So I basically had an endowment. Do I understand correctly?
No, they sell their rights. So in that way, they have not an endowment. They get the lottery for free, or if you want to say, we endow them with the lottery, and they can sell them to us back.
Mhm. I see.
I have some more methodological questions, if that's okay.
Sure.
So first, you presented, Sebastian, as a correlation between valuation and choice for the first study, but I thought that the first study was between participants. Maybe it wasn't?
No, they were always in. So valuation and choice was always within because we're interested in this preference reversal and the correlational structure. Yeah, always in.
And then when you fit your model, so omega gets the value per person, per participant, or
Yes,
are you
in
doing
terms
it kind of?
Yeah.
Okay, thanks.
And this is online experiments, right? Or physical labs?
I think they are all online, but we also had data in the laboratory. But I think these one I presented were all online. Yeah.
By the way, what your model does about underweighting of rare events, it implies some, like maybe overweighting of positive and underweighting of negative.
I mean, the selective integration also predicts a frequent winner effect. So in that case, yeah, if we have a like a rare event structure where most of the other outcomes are then on the opposite side, so that there's a clear frequent winner, then it would predict towards the frequent winner. If you, I don't know, rig it somehow that there's only rare events, I don't know, because yeah, we just have normal distributions here.
Okay.
Okay, guys, yes, Yeda, go ahead.
No, go ahead.
No, I said unless we have other questions.
Well, I'm just saying it's an open question. If there's a difference between the frequent winner hypothesis and the reliance on small sample hypothesis, have you thought about that? Is there a way to distinguish between these two hypotheses?
Yeah, I think just more refined. I mean, one way I think you could go is have more refined choice problems that maybe mix the degree of frequent winning and of, for example, variance effects and so on, right? Because I think so far the qualitative pattern, yeah, frequent winner matters, variance matters. Many models can capture it, but the only idea I have to distinguish it to look at the combination of the two and how they quantitatively, like which one predominates in if you vary things at the same time.
But in a way, you can say that that the small samples models kind of go down to maybe a lower process that creates the frequent winner. So you call their model kind of more descriptive in a way. So it is a process, but it's more descriptive or something. And then the reliance of small samples can be the cognitive process that creates them, right?
Yeah, no. It's two hypotheses that explain similar. It will be interesting to know if they thought about the experiment to test it too. Maybe there are. I'm not sure. I haven't worked on it.
Thank you so much, Sebastian. This was a great talk.
Yes,
you.
thank you. It was very interesting. We are approaching the end of our seminar. So thanks for your time, and the formal part will be over now. So those who have to leave can go, and thank you. And now we'll have a few more minutes of informal discussion, so I'm closing the recording right now.
Thanks, everyone.
But usually you don't close the recording during the
This is
informal.
because I usually forget